This video is about range, interquartile range, lower quartile, upper quartile, lots of things like that. But it is also about medical treatment, medicine, saving lives. Suppose you have these two medical treatments, Spluesma and Glorpsdup. Do you know that with Spluesma there have been 20 medical studies on this drug, and the same is true for Glorpsdup? The average fatality rate for Spluesma is 5%, and the average fatality rate for Glorpsdup is 5%. You're in charge of public health and deciding where the money goes. Which drug do you suggest? There's not enough information, is there? They seem to be pretty similar, but in reality, one of them is more dangerous than the other. It's riskier. If I give you the fatality results for Spluesma, you can see that in each of the studies, the result was 5% fatality. But in Glorpsdup, most of them had 0% fatality. But in one study, maybe in one place or one group of people, there was 100% fatality rate. The results here are much more varied than this one. And you probably don't want that if you're making a safe drug. So that's where we have these useful concepts of spread and range and IQR. If the results are like this, most of them are close to the same value, we say that it is low spread. The results are more consistent, there's less variation in the results, the range from smallest to largest value is small, and what we'll see later, the IQR is also small. These are all hints that there is low spread. But maybe the results might have higher spread, like that more dangerous drug, where they're more spread out. It's less consistent, sometimes it's really large, sometimes really small. There's more variation, different ways of saying the same thing. The range is very large. You can see the range goes from 1 being the smallest value to 9 being the largest. And the IQR is large. It's useful to have numbers for scientists and, politicians to make decisions with these things about, drugs, for example, which are more consistent or less consistent. And the numbers that will help us are the range and the IQR. Let's see how that looks. By the way, you can see that this one has small spread, whereas this one is very spread out, higher spread. So let's look at those figures, range and IQR. There are a few statistics, like range and IQR, that we can figure out. The first one that we're asked to figure out for this data set is the median. Remember that the median is in the middle. You can't just look at the one that you think is in the middle here because they're not in order yet. We need to put them in order and then get the middle one. So to find the median, you put them in order and pick the middle one. Here there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 results. So there will be a number in the middle because there is an odd number. And if you can trace with your fingers from one end and the other, one at a time, 1, 2, 3, 4, 5, 6, 7. So I've made a group here of 7 numbers on the left and 7 numbers on the right so that there is just one number left in the middle. If there were an odd number of items, then that's okay. You just wouldn't end up with a number in the middle. You'd have 2 even groups without one left over. Anyway, so we can see that this number 5 is in the middle now. Put it in order and pick the middle item. So the median is 5. To find the range, we want the largest number minus the smallest number. In other words, the range is the max minus min. The maximum here is 9, minus the minimum, which is 2. The range is 7. The range gives you an idea of the spread. A large range means the results aren't very consistent. They're very spread out. And you can see they are really spread out. It goes all the way from 2 to 9. That's a big range. Let's have a look at these two things that will help us calculate this mysterious IQR. The lower quartile and the upper quartile. The lower quartile is also called Q1, and the lower quartile is the median of the lower half. You see up here that I've got this lower half of 7 items here, so the lower quartile is the median of this bottom half. And the median is the middle. There are 7 items here, so conveniently there is one item in the middle, which is this one. This number 3 is the median of this lower half. It's the middle item. So the median, or the lower quartile is 3. The lower quartile is also called Q1. The upper quartile, similarly, is the median of the upper half. I've got 7 items here, and you can see the middle one is right here, number 7. Upper quartile is number 7. Now remember, if you're figuring out the median, maybe there are 2 numbers in the middle. You know, if there were 8 numbers here, there would be 2 numbers in the middle. And if there are 2 numbers in the middle, you take their average. Let's try finding the IQR now, the interquartile range. To find the interquartile range, it is that the IQR, interquartile range, is Q3, which is this one, minus Q1. This number gives us a really good indication of how spread out the data is. If it's really big, the data is not very consistent. So let's calculate it. IQR equals Q3 minus Q1. We've already calculated Q3. Q3 is 7 and Q1 is 3. You can see 7 take 3. So the interquartile range is 4. So this is how to crunch the numbers and get the median, the range, lower quartile, upper quartile, and interquartile range. Later, we'll see how we can compare data sets by comparing their interquartile range. You know, for example, to see which drug is safer. I hope this has been helpful, and I'll see you next time. Bye, everyone.